The next abstraction level is the stage level. Several repetition of a block module in a chain pattern gives you a stage module. In addition to the built-in stage modules, you could create your own customized stage module using the stage construct. The built-in stage modules include bypass, inputs mapping, and multiplexer. The stage construct comes with 4 parameters: block, repeats, pre-block, and aggregator. The block parameter specifies the block module that will be repeated inside the stage module in order to create a chain of block modules. Repeat parameter is the number of times that the block module specified by the block parameter will be repeated. The pre-block parameter is optional and specifies the pre-processing block. If pre-block is not set, then the output of the aggregator will be passed directly to the chain of blocks. However, if pre-block is set, then the output of the aggregator will be passed first to the pre-processing block, and then the output of the pre-processing block will be passed to the chain of blocks. The aggregator parameter characterizes how this stage module processes its incoming edges as a node in a graph in the next level of abstraction, which is graphs of stage nodes. First, we set the block parameter. From the drop-down menu, we have essentially 3 options. The first option is to create a brand new block using block CFG. The second option is to choose one of the built-in blocks, which include res block, bottleneck res block, and pointwise feed-forward block. The last option is to choose one of the previously added customized blocks to our personal library. Here, our personal library has a single customized block called demo block that we added previously. First, we inspect the built-in res block. We see that we have access to all the parameters of the residual block. After inspecting the parameters of the residual block, we decide to use the demo block as the block of our stage module. Selecting the demo block, we have access to all the parameters of the demo block, either to inspect them or change them. As we created previously the demo block, we observed that the demo block has 2 post-processing layers, where the last post-processing layer is the ReLU layer, and the first post-processing layer is a linear layer with the input size of 16 and the output size of 64. Next, we set the repeats parameter to 3. Setting repeats to 3 results in repeating the demo block 3 times in order to create a chain of blocks. In order to save our progress so far, we add this stage to our personal library under the name demo stage. Different from the block parameter, the pre-block parameter is optional. However, if you decide to set it, then you will have the same options as block parameter. Here we assign a brand new block to pre-block parameter using block CFG. This brand new block has a single linear layer with the input size of 16 and output size of 16. Next, we click on checkmark buttons in order to apply our changes. After setting the repeats, block, and pre-block parameters, the next step is to decide what we want to do with aggregator parameter. If you plan to use this stage module as a graph node that only takes one incoming edge, and also the object received on that single incoming edge could be passed either directly to block or pre-block, then you don't need to set the aggregator parameter. On the other hand, if your use case doesn't align with these conditions, then you need to set the aggregator parameter. 2 main parameters of the stage aggregator config are aggregator and mappings. The aggregator parameter of the stage aggregator config specifies how the objects received on incoming edges of a stage node will be aggregated to a single object. The mappings parameter determines how the target objects are being picked up from the incoming edges before passing them to the aggregator. In order to set mappings parameter, you have two main options. Either to choose a single inputs mapping config and apply it to all the incoming edges, or to choose a list of inputs mapping configs. If you go with the second option, then you need to know beforehand the exact number of the incoming edges for the stage node, because every incoming edge gets its own designated inputs mapping config. Therefore, the length of the input mapping configs list must be equal to the number of the incoming edges. For this example, we go with the default value for the mappings parameter, which is a single inputs mapping config. Being a single inputs mapping config, this stage node could accept varying number of incoming edges. Here we select the addition as the aggregator of our stage node, which means that the tensors arrived on incoming edges of the stage node will be added in order to create a single tensor that will be passed to the pre-block.